In this video, I'm going to show you the control plane topology poisoning attack, which we call Marionette, by deploying two connected virtual machines on Cybervan testbed. One is the Marionette virtual machine, which stimulates the OpenFlow network topology with 5 switches and 2 hosts. The other is the OpenDaylight controller with the malicious Marionette application located on the same machine. Now let me connect the Marionette with the controller. Alright, it was connected. And I am going to pull the topology from the OpenDaylight. As you can see, this is the original topology. The host 1 is attached to OpenFlow 1 and the host 2 is attached to OpenFlow 3. Next, let's test the proactive shortest path routing service. The pre-configured flow is from host 1 to host 2. Let me start a ping from host 1 to host 2 first. At this moment, the ping won't work because we haven't configured any flow entries yet. Let's start the shortest path routing service. The shortest path routing gets the real-time topology information from the topology manager and computes the shortest path from host 1 to host 2, which is host 1 to OpenFlow 1 to OpenFlow 2 to OpenFlow 3 to the host 2. The corresponding RP and ICMP flow entries are sent to the Marionette. The ping on the Marionette starts to work, as you can see right now. Now we're going to attack. By running our attack program, the modular extracts the real topology information with the pre-configured vulnerable switch as the OpenFlow 5. It starts reinforcement learning to compute a deceptive topology that can make the flow of host 1 to host 5 go through OpenFlow 5. During the period of reinforcement learning, let me give you a quick view of the reinforcement learning module. In our reinforcement learning module, the action is reallocating a random node to a random location, but always maintaining the same degree sequence of the topology graph. After the reallocation, we compute the shortest path routing based on the updated graph and see whether the vulnerable switch is on the shortest path or not. If yes, the reward is 1, otherwise the reward is 0. We also have some bonus design here, such as if the vulnerable switch can be hidden from the benign controller, and we will give it a bonus. Alright, the deceptive topology computing is done. It starts to poison the topology. The latest topology changed accordingly, as we can see. Due to the change, the shortest path routing service recomputes the shortest path routing, which turns to be OpenFlow 1 to OpenFlow 4 to OpenFlow 5, and resends the flow entries. Okay, so you can see that the pings stopped working because of this change. To maintain a persistent attack, the gap patching modular monitors the flow entries set by the benign controller. When it detects a flow entry leading to a gap, it sends a gap patching flow entry to patch the gap accordingly. In our case, the gap is on OpenFlow 5, which will be patched. After this, the ping starts to work again. That's all. Thank you.